So far, we have learned about data types. We are storing individual pieces of data. And so we have a number, a string, a boolean. But what if we want to store a collection of pieces of data? So for example, let's say that I'm a scientist and I'm running a science experiment that generates a bunch of numbers related to an experiment that I'm running. So, and I want a way to store all of this data in some ordered collection. How do I do that in Python? Well, fortunately, there is a data type exactly for this idea for storing an ordered collection of items, and it's called a list. So let's go ahead and play with lists in Python. So first things first, how do we define the list? Let's do one by example. So your list equals, and we know a single equals is an assignment. And then the key to list is a square bracket. Square brackets means we are dealing with lists. So your list equals, and then it is a comma separated set of items. So in this case, let's just give it a couple of strings. So let's say A, comma, B, comma, C, all inside square brackets. And this assignment will produce 3 items. 3 different strings. So if we press return, that creates the list, and we can always review it by just typing the variable and pressing return, and we can use that type function from earlier to confirm that this is in fact a list. So the type of your list is in fact a list. Like strings, lists have some notion of the length, how many items are in the list. So actually this len function that we first used with strings, we can actually reuse with lists. So the len of your list is in fact 3. Also, like with strings, there's a containment with lists. So before we had said h is the string, h in the string hello, and that evaluates to a boolean true. We can similarly check for containment within the list. We could say, is the string A in your list? And sure enough, it is. Is Z in your list? No. Is Z not in your list? Exactly. So we can access individual elements in this list, and the syntax with this is a little funny. Let's do it and then talk about it. So let's say that I want to get the leftmost item of your list. I want to get that. How do I do that? Well, we provide a variable name your list, and then inside square brackets the index of the item that we want. Now in this case the index is actually 0. Python starts counting at 0, and this is just a historical artifact. A lot of programming languages start counting at 0, but that is the leftmost item does in fact have a index of 0. And so by extension, and remember we can use our up arrow to go back through previous lines that we have executed. So by extension 0, the first item of this list is the B, and the second item of this list is C. What happens if we try to look up the third? Well, the 0th, first, second, third item in this list given the contents right now. Let's try it out. Right. No problem. So Python produces a traceback. It says there was an index error. The list index is out of range, and fair enough, because your list only has 0, 1, 2 items in it. Well, fortunately we can add new items at the end of this list, and the syntax for this is a little funny as well. So let's do it and then talk about it. So we could say, so let's say we want to add the string D, the item we could say your list dot append, and then append is a function. We know it's a function because of the parenthesis. So inside the parenthesis for the append function, the item that we want to append the string D. So your list dot append D. Now if we look at your list, sure enough, we have a new D at the end. So what exactly is going on here with this syntax for appending? Well, your list is a list. It's a variable that points to a list. And then lists have lots of operations that you can do on them. You can append, you can insert in other places, you can remove things, you can find things. And the way that Python sort of associates a collection of operations with a particular data type, the syntax for this is with this dot and then function name structure. So on the list, your list dot the name of the function you would like to invoke, and then inside parentheses the arguments for that function, and we will see that there are many other functions using this dot name syntax that we can use on a particular list. So append is a function that you can use on this list to add items to the end. And now that we have done this, we can check with the, in fact, your list has grown now. Look at this. And we can now index into this list to pull out the 0th, 1st, 2nd, 3rd item, and it is in fact D. Well, now here is a question. Given what we know so far about lists, how would we create an empty list? Well, let's say her list equals, and we know that the way that this is with a comma separated set of items inside square brackets, so we have no items. It should just be open, close, and the length would be what we would expect, 0, nothing inside. Or we can replace items in a list. So let's build up a list of names to experiment with, to replace with. So let's say that we are forming a band. So we have Alice and we have Amy, and they are singers in the band. And they say, okay, well, we need a guitar player. So we are going to add Adam to this list. We are going to append the name Adam to the end of this list of names. So names dot append Adam. Once we do this, if we check the contents of names, sure enough, Adam's at the end. Maybe we say, okay, Alice is spending too much time with the stuff, and Alice is failed. Jimmy is in. So how do we replace Alice with Jimmy? Well, first we have to find Alice. How do we do that? The same square bracket syntax from before. Alice is the leftmost item in the list. So we say the index, the 0th index inside brackets. We know that pulls out Alice. So that's part one of that's a replacement. So we pull out the item and then we do an assignment. So given the 0 index, we are going to replace it with Jimmy. Name 0 equals Jimmy. After we run this, if we look at names, sure enough, Alice is out and Jimmy is in. We could say, okay, Adam wasn't cutting it on guitar. How do we replace Adam with Rachel? Same as before. So if we count Adam as the 0th, 1st, 2nd item in this list, so names 2 and then do an assignment to the new band member. And remember here, single equals is for assignment. Double equals is for comparison. Okay, let's add a horn section to this band. So names dot append. Maybe Tim is on sax. Maybe Bob is on trumpet. Maybe Alexis is on the French horn. And now we have a nice long list of names. How many names? Well, we can check with the length function. And here is a question. We know how to index from the left. We know that 0 is the leftmost item and 1 is the next leftmost, at etc. How do we get elements of the end of the list? What if we wanted to know who the most recently added band member was? How do we do that? Well, there are at least two ways. There is a sort of hard way and an easy way. Let's do the hard way first. Just a thought experiment. So how do we find the index of the last person in the list? Well, if we start counting, we know it is 0, 1, 2, 3, 4, 5. How do we get that number 5? Well, we know that we have this function len. That will give us the length of the list. And we know that we start counting at 0. So we know that the length of names minus 1 to account for that 0 offset will give us the index of the last item in the list. So we could take this and use it inside our square bracket syntax to pull out the last item. There we go. But there is actually an easier way, which I think math majors in the room will like. You can actually use negative numbers. So we can say names -1 and that will pull off this from these. So -1 is Alexis, -2 is Bob, -3 is Tim, etc. So that's pretty cool. We can index, we can add individual items in a list using positive numbers to start from the left or negative numbers to start from the right. So we have already seen a number of ways in which lists and strings are very similar. They both have a notion of order. They both have a notion of containment. We can get the length of both the list and a string. Here are a couple of other ways in which they are similar. So we know that we can access individual items in a list with this square bracket syntax with an index. And we can actually do the same thing with strings. So I could say my name equals the string. Let's bring the name Jessica. And then I can use the same square bracket syntax to pull out individual letters from this string. So if we want to get the leftmost item, the 0th item, I can pull it out that we would with the list. By extension, negative number is to wrap from the end. We have learned a bunch of really useful operations on lists. Let's quickly review them. So let's get a new list to work with, a list of fruits. So we can say, okay, here is how we create a new list. An equal sign assignment with the items. The comma separated set of items inside square brackets. So in this case, we have a list of fruits. We know how to extract individual items from this list. For example, the leftmost item, the 0th item. We know how to pull items from the end of the list using negative numbers. We know how to reassign items in a list. So we could say replace apples with plums. Using this sort of square bracket and then assignment syntax, we can add items to the end of a list with this append function. Lists have a length. There is a notion of containment. So a bunch of really useful operations that we can do on lists. So we have been learning a lot of useful operations on lists. But how did I know that these operations existed? How did I know that you could append items at the end of the list with this append function? And the answer is not that I have memorized all of this stuff. I haven't. In fact, I have a terrible memory. The way that programmers get work done is through excellent documentation. And it is important actually to be comfortable with the idea that you might not know how to do something and you might need to look it up. This is a fundamental programmer trait, being willing to look up stuff that you don't know. So why don't we go ahead and actually practice this? And in truth, this is not very exciting. I don't have any super secret tips here. All I'm going to do is go to the internet browser and search for stuff. So let's say that our question is, what else can we do with the list? Here is how I would look this up. I would go to my web browser of choice and I would literally just type Python list. Press return and I would look at probably the first link, which is for the official python.org documentation. I would click on it and I would see this really nice table of contents summarizing all of that you can do with the list. And if you scroll down, we see a lot of stuff. Here is our append that we have already used. We can see that you can insert items at arbitrary places in list. We can remove items. We can find the index of something. We can count how many times something is in a list. We can even sort them. So this is what I would do. If I wanted to know what operations were possible in lists, I would just Google for it, honestly. I mean, this is going to be a very common thing that we need to do as we develop fluency in the language. So here is another example. What if we wanted to know if it is possible to lowercase a string? To know if there is the lowercase, how would I do that? I would just say lowercase string Python. What's the top list? All right, that is a programmer question and the answer. Website called Stack Overflow. Someone is asking exactly this question. And here's the top answer. There's a dot lower function. So strings have a lower function. That will take a string and lowercase all of the characters in it. So there you go. But don't feel like you have to memorize anything. Don't worry about not knowing a particular detail. Just get comfortable with the idea of looking it up. Now, in truth, the real superpower when using lists is actually to be able to loop over them. And so looping over lists, iterating over lists is what we are going to talk about in the next section.